All right, so what we are going to go to now is called a cancellation rule. And how do we use it? Well, first, we have to find the prime factorization of whatever's there in the numerator and denominator, and then we cancel all the common terms out, okay? And so here what we're going to do is we're going to make factor trees to help us find the prime factorization. So factor trees are going to be our friend. What is the factorization tree? Well, it's a tree we make starting at the top with the number to be factored. So, in this case, it looks like we're going to do 66. And then we break it down into prime factors as we move down the tree. So what does that mean in practice? Well, we're going to start with 66 and we're going to go into prime factors. Well, I'm going to divide by 2 because I know that's divisible by 2, and that's a prime factor. And so I can stop with that number, and so I'll circle it. Well, 2 times what is 66? Well, 2 times 33. So on our same level, we have our two numbers. Now 33 is not prime, so I'm not going to circle that because 33, I can factor that again. Well, I can see I take a 3 and divide out, and I'll have another prime number. And 3 times what? Well, 3 times 11. Well, is 11 factorable? No, it's a prime as well. And so now my prime factorization of 66 is going to be 2 times 3 times 11. Okay. And so those are my factors. And then what would happen is if I got another number for the denominator, I would write its factors. And then I could write one set of factors over the other and then cancel any of them on top and bottom that are the same. Okay, and so that's how it's going to work. So this factorization tree is going to be how we do simplifying it instead of go back, instead of coming up all these factors, we're just going to do a factorization tree, and then we can cancel top and bottom whatever is divisible, and that will cancel. So we're going to use factorization trees now to do this. And so what we need to do is we need to come over here and find out the factorization of 28 and 35 with prime factors. Well, when I see an even number, my first choice is always going to be a 2, and then I can circle it, and I'm done on that side of the tree. And then I go to the other side of the tree. Well, 2 times what is 28? Well, 2 times 14. Now, 14 is not a prime factor because I can divide that by 2 again. And so I'm going to say, okay, well, I'm going to put 2 over here. And 2 times what is 14? Well, 2 times 7. Now I have to kind of know factors that are prime. And well, 7, guess what? That's a prime factor. So I'm done. All right. So what I'm going to do is I'm going to rewrite 28 as 2 times 2 times 7. Okay. And then that's going to be over. Well, now I'm going to do a factor tree here. All right, well, when I see a 5 on the end or a 0 on the end, a nice factor to use would be 5, that's prime. 5 is a prime factor, and so I'm going to divide that by 5. And 5 times what is 35? Well, 5 times 7. Well, over here I said 7 was prime, so it better be prime here again. So now I'm done. I don't have to do any more. So 5 times 7. And now with the cancellation rule, it basically says cancel what's in numerator and denominator that works. Well, 7 cancels 7. And guess what? I'm done with this problem and reducing it in the fact that now I just have to say 2 times 2 is 4, 5 times 1 is 5, and that is my reduced fraction. Okay, so much easier than trying to find all of the factors of 28, all the, or actually not factors, but divisors of 28, all the divisors of 35, find the greatest common divisor, and then divide both sides by that. And if we would have done all those things, we'd have found 7 was our greatest common divisor, and then we would have got that. But again, that takes time. And this was pretty simple, it wasn't too hard. What about 22 and 98? Well, let's go ahead and take those down. So I know on the left, I'm going to put 2 because they're even. So I'm just going to kind of work these as we go. Well, 2 times what is 22? Well, 2 times 11 is 22. Now 11, well, guess what? We're done there because that's a prime number. So 2 times 11. Well, what about 98? Well, 98 divided by 2 is going to give me 49. Now, is 49 prime? No, that actually is 7 times 7. and then I have 2 more primes, and so this is actually going to be over 2 times 7 times 7. Okay, now back to canceling what's top and bottom. Well, the only thing it cancels is the 2, and we still have that 11 and basically, oops, the 49. So if we change back here, we'll have 11. 7 times 7 is 49. And then we have our reduced form. So sometimes, we reduce it all the way to the primes, and then we have to do some multiplication back, but that's a lot easier than going through all the divisors of 98 and finding out the only ones that were 2 on both the numerator and the denominator. Okay. All right, what about 44 and 62? So, well, let's write those out and see what we have. 44 and 62. Well, with 44, I see it's even, so I'm going to divide by 2 so I can get my first prime. And 2 times what is 44? Well, 2 times 22 is 44. 22, we just did that one, and we said that was 2 and 11. And so our factorization of 44 is 2 times 2 times 11. All right, what about 62? Well, that's also divisible by 2, so we can get our first prime. 2 times what? Well, that's going to be 31. Okay. Now, 31, we would have to work through all our multiples, but guess what? That is a prime number. There's nothing else we can do here. So it's just 2 times 31. So again, it looks like we did all of this just to find out we can only cancel out those 2 2's. But that's still a lot easier than going through and finding all the divisors of 44, all the divisors of 62, and then reducing it that way. And then we just have to remultiply. That's 22 over 31. All right, what about 25 and 60? And again, anytime you want to, go ahead and pause and practice on your own, and then see if you get the same thing as I do. So 25, well, that's divisible by 5, so I'm going to have that as my first prime. And 5 times what's 25? Well, 5 times 5. So my numerator is just 5 times 5. Now here, I see we have a 60. Well, I know that's divisible by 5 as well. And 5 goes in here 1 and 2, so that's going to be 2. Or 12. And so that is not prime. So we have to divide by 2. 2 will go in here 6 times. Well, that's not prime either, because that's going to be 2 times what? 3. Now I have primes. So I've got all the primes here. So that's going to be 5 times 2 times 2 times 3. Now notice only 1 5 cancels, but that made it still much simpler finding all the primes. And we're going to be using that to do other stuff. So it's always best to go all the way down to all the primes. And no matter what, even if you see that, hey, I only have 5 and 5 in common here, and then I'm done. It's always best to do them all because it's easy to multiply back by. So 5 is on numerator. 2 times 2 is 4 times 3 is 12. And that then is a reduced fraction. All right, I'll pause there.